send me the text with the question number. Yeah. Okay, Siddharth, I have received your message. Question number 6 and 10, we will be discussing that. So keep sending me the text messages with the question numbers. I just want to discuss a couple of more things related to application of pseudo force first, and then I will come to these doubts. Okay, Sanvi, I have received your message also. Question number 5. Okay, Siddharth. Very good. So, as I said, just a couple of more applications of pseudo force I want to discuss. Then I will come to the doubts from H.C. Verma. And after doubts from H.C. Verma, we will also discuss questions from the module exercise before we move on to friction, which will most probably be in the next lecture itself.
Sir,
Yes.
sir,
Yes.
sir, can you send today's recording because I'm traveling now, so I want.
Okay, I will send it as soon as possible. Okay.
Excuse me, sir. Are you saying something because I cannot hear you? Hello?
Yes, I have been speaking better. You should be able to hear
Sir,
me. The audio is,
are you saying something?
yes, the audio is pretty clear from my side. Are
Hello?
others able to hear me? Yes.
Yes, sir.
Okay, okay. So yeah, so I Khushi, what I suggest is that you can reconnect once if you like. Okay, Sanvi, the problem is at your end, is it? Okay. So it might be an issue with your internet connection, or it might be an issue with the audio system. Just check once more. Check your speaker connection or your headphone output or whatever you're using for audio. There is also a feature in Zoom by which you can do an audio test. Okay. Yes, I will send the recording definitely. Okay, but just saying, just for a moment, I'll show you how you can do the audio testing on Zoom. Okay. Just a minute. So you have to go to this icon which has the audio part. Okay, and click on that arrow over there, and it says test speaker and microphone. So when you do that, get this kind of a, so you can check both your input as well as your audio output. Okay. So Sanvi, maybe you can try that once, or maybe you can try it later after the class. Okay. So this section basically. Okay, so I'm going back to the part of the lecture now. So free body diagram in non-inertial frame and application of pseudo force concept. So we'll discuss a couple of more examples of this. So now, for example, if we have a situation like this, that we have an elevator which is accelerated upwards at a uniform acceleration a naught, and inside the elevator there is a inclined plane, smooth inclined plane, which is at an angle of, let's say, 30 degrees. Smooth inclined plane. And a block or a box or whatever is released from this position inside the escalator or inside the elevator. So given that the elevator has a uniform upward acceleration, uniform vertical acceleration, of, let us say, 4 meters per second square, and g is equal to 10 meters per second square, and the block placed on the smooth inclined plane mass 2 kilograms. So we have to find, first of all, E, that is the acceleration of the block with respect to the frame attached to the inclined plane. So it's with respect to the reference frame attached to the inclined plane. And secondly, the normal contact force. How much normal reaction is acting on the block. So these two things we have to calculate. So what you will have to do here is you will have to make the FPD of the block in the elevator's frame. Okay. That is the inclined plane. So that is a non-inertial frame. So in the FPD include pseudo force, and solve Newton's second law, but the new second law with the adjustment of the pseudo force included. So from that you will find the acceleration A and the normal reaction, both things. Now what do you remember about pseudo force? That it should be equal to mass of the object or mass of the free body multiplied by acceleration of the frame. So here the acceleration of the frame is A naught. So the magnitude of the pseudo force should be m into A naught, and the direction should be opposite to the acceleration of the frame. So as a vector, the pseudo force is minus m A naught. So A naught is in the upward direction. So the pseudo force is acting vertically downwards on the block. So now just try this out. Make the free body diagram with the forces. Okay. Can anybody tell me how many forces are acting on the block in total? When you make the free body diagram, how many forces will be acting?
Normal reaction in upward direction, A cos theta in downward direction, followed by pseudo force in downward direction, and A sin theta in the horizontal direction.
What about weight? Weight is also acting now?
Yes, sir.
Okay. So in all, you will see that there are three forces, right? Pseudo force, normal reaction, and weight. And then of course you have to resolve the forces accordingly, right? So the A sin theta, the pseudo force is cos and sin component. That will be according to how you have taken the inclined plane, rather the XY system, the coordinate frame system. Siddharth, just check your answer once. The normal reaction answer is not correct. There will be an under root 3 term, but it's not exactly the term that you have written. Okay, so I will start by making the free body diagram. So if we are looking at the block as an observer fixed to the inclined plane, okay, so that observer is the non-inertial frame. It's going up with an acceleration p0. Okay. So this observer will see the block accelerating down the inclined plane at E. And in this frame, the forces acting on the block are the weight of the block, the normal reaction the surface is applying. These two are the standard forces. But apart from that, there will also be pseudo force. This is a pseudo force. Okay. So these all forces will be acting. Now, because the acceleration is down the inclined plane, so what we can do is we can take our system of axes such that down the inclined plane is our x-axis and normal to the inclined plane is our y-axis. So if this angle is theta, you can see here this angle is theta. So now when we make the proper FBD with all the forces resolved and all, again in that non-inertial frame only, the non-inertial frame of the elevator. So that is going up with an acceleration a0. So now we will show the forces in the resolved form. Okay. So pseudo force will have one component along the negative y-axis and one component along the positive x-axis. So m a0 cos theta, m a0 sin theta. Okay. And similarly, mg will also have two components. Mg cos theta and mg sin theta. And then you have the normal reaction. And then in this frame, we understand that this particle is having an acceleration like this. So along our y-axis, we have normal reaction balances mg cos theta plus ma0 cos theta. So that is going to be m into g plus a0 cos 30 degrees. What was it? 4, right? 3 by 2.
Sir, mass of the block is 2 kgs, no?
Yes. So normal reaction is this much. Okay. So that's approximately 14 into 1.4. And similarly, along the x-axis, you have mg sine theta plus ma naught cos theta is equal to ma. So you have the acceleration as g plus a naught sine theta, and theta here is 30 degrees, m was 2 kgs, a naught is 4 meters per second square, and all that. So my acceleration with respect to the inclined plane is 7 meters per second square. This is the acceleration with respect to the elevator's frame. Okay. Or you can say the inclined plane. So the inclined plane lies in the elevator's frame. Same object beta. We have just resolved the forces. This is the FBD with forces resolved. This is. So Ethan, along the y-axis, the forces are balanced. No? So the normal reaction is balancing the forces which are pressing the object against the surface. See what is happening? Normal reaction is a reaction force that the surface applies. ना अभी क्या हो रहा है? Weight का जो component है, जो along the, I mean into the surface है, that component is mg cos theta. Okay, pseudo force का जो component है, that is pushing the block against this, that is ma cos theta. So these two are pushing the block against the surface. So the surface is applying an opposite force to balance these. So here you can see that normal reaction, that N, it balances the sum of mg and ma's component into the inclined surface.
What you have written after balances though?
Sum, the sum of mg and pseudo forces components into the inclined plane. Not ma beta. Okay, because the acceleration along the y-axis is 0. No? The acceleration is there along the x-axis. So the net force along the y-axis should be 0. No? Okay, so that's then the same thing. No? Like n minus mg cos theta minus ma sin theta, ma cos theta is equal to 0. So that's now the same equation. Okay. So because the acceleration is along the x-axis, so your x-axis equation is like this: that net force is equal to mass into acceleration. Whereas your y-axis equation is actually net force is 0. Ma naught term is not for acceleration. Ma naught term is for pseudo force. No? So acceleration of the block in this reference frame is A. So the term A naught is coming from pseudo force, not from acceleration. Okay, so now that we've understood this example, now we'll see a slightly different version of this situation. Yeah, they can, but see, not on an inclined surface. Right? A surface is supporting the object, no? So it will always prevent it from moving perpendicular to itself. You understanding? No? Like when a block moves on a horizontal surface, it can't have a vertical acceleration. Okay, let's look at our next example. So very similar situation, but this time the reference frame is having a horizontal acceleration. It's having a horizontal acceleration of 5 meters per second square. And inside the reference frame, there is a smooth inclined plane, which has an angle of inclination this time of 37 degrees. Let's say this is a vehicle which is having a uniform acceleration like this. And inside the vehicle, there is an inclined surface like this. So again, if we release a block of a certain mass, we have to find its acceleration and the normal reaction. So m is equal to 5 kg this time, and g is equal to 10 meters per second square. Find the acceleration of the block with respect to the inclined plane and the normal reaction. So once again, this equation is like this: a smooth inclined plane fixed inside a vehicle moving horizontally at a uniform acceleration. That is the situation. Okay, Ethan, I will take you back to writing the previous question. Let people who have completed that just take down the details of this question, then I will take you back to the solution of the previous question. So those who have finished writing down the previous question, please take down the values and the details of this question so you can get started on trying to solve it. Okay.
Sir, this is it. We have to start solving, no?
Yes, if you finish the previous question's solution, now come to the free body diagram. So once again, here in this question also, what you should do is you should make the FBD of this block in the non-inertial frame. So the only difference is the direction of pseudo force will have changed because now it's horizontally accelerated and not vertically accelerated. But the concept is the same. You make the FBD in the non-inertial frame to solve the question. No, beta. Normal reaction will not be mg cos theta alone. Pseudo force will also have a component, so it will affect the normal reaction. Now you make the FBD properly with pseudo force to understand whether normal reaction is becoming greater than mg cos theta or less than mg cos theta. Understood the point, Siddharth? If it had been a stationary frame or a ground frame, then the normal reaction is mg cos theta, so it would have been 40 newtons because m is 5 kg.
But sir, the block is moving on the right hand side, no? So the pseudo force will act on the left hand side, no?
The object, the reference frame is moving towards the right, so the pseudo force is towards the left. So it has a component now which is perpendicular to the inclined plane. Your normal reaction is not vertical, na, beta? So pseudo force and normal reaction are not perpendicular to each other, so they affect each other. Make the vector diagram properly, you will understand. What is the angle between pseudo force and normal reaction? See, it won't be 90 degrees. Okay, so let's figure out the answer. Yeah, I'll check the solution, Siddharth. I mean, your answer. Okay. As long as you've taken the values correct, I think it should be okay. So once again, if we take first, we just have a general idea of the forces acting, and then we make the detailed free body diagram. So this time, our observer on the inclined plane, he is a non-inertial observer who's himself traveling with an acceleration like this, horizontally like this. So the pseudo force acting on the block will be horizontal and opposite in direction. So the pseudo force is like this, whereas the other forces are the standard type. The gravitational pull of the earth, or mg, is vertically downwards, and the normal reaction, the surface applies, will be in this sort of direction. This is a normal reaction. So once again, we have to take our inclined axis like this, and the object will be accelerating along this sort of direction. So here E is the acceleration relative to the inclined plane. And of course, if this angle is theta now, you can see this angle will be theta, or this angle will be theta. So with respect to our x and y axis. So now we'll make the FBD with the resolved forces. Okay, and we'll make it in the vehicle's frame, which is the non-inertial frame. Okay. So with the resolution now, the forces will be like this. MA sine theta, rather MA naught sine theta, and MA naught cos theta. Then MG's components, MG cos theta in this direction, and MG sine theta in this direction. And normal reaction in this direction. So this time along the y-axis, we have the equation that n plus MA naught sine theta is balancing MG cos theta. And along the x-axis, we have MG sine theta plus MA naught cos theta is equal to MA. Okay. So now we can solve these two equations to find out the normal reaction and the contact force, both the things. Now here E naught is 5, theta is 37 degrees, and M is also 5 kg. Of course, we are taking the standard value of G as 10 meters per second square. So from equation 1, you can see that normal reaction is mg cos theta minus A naught sine theta. So that will become 5 into 10 into 4 by 5 minus 5 into 3 by 5. Okay. That will be 8 minus 3, 5, so it will be 25 newtons. So a normal reaction will be 25 newtons. Just check the calculation once you set. Okay.
Yes, sir, it is correct.
Yes, from equation 2, we should have E is equal to G sine theta plus E naught cos theta. So that will work out to be 10 into 3 by 5 or 6 plus 5 into 4 by 5 or 4. So the acceleration will come out to be 10. Interestingly. Okay, people, so hope this question is clear. Now we'll come to the HC Verma doubts. So I'm going to, as per the text messages I've received, just writing down which all questions we are looking to solve. So we have questions 6, 10, okay, 5. Okay, let's see. Just listing out the questions here. 5, 6, 10, 15. 20, 28, and 32. Okay. So these are some of the questions we'll be solving from HC Verma. Okay, 19 and 21 also. Okay. Okay, so let's look at HC Verma questions. Next. Okay, understood, Siddharth. But I'll need to explain the whole question. Okay. So let's start with question number 5 from HC Verma.
Excuse me, sir. So actually, I sent 5 by mistake. It's 8.
Sorry, Sanvi, beta, which one? 5 and?
No, sir, not 5. Actually, I sent it by mistake. It's
Acha, 5 is by mistake. Then which one?
8.
8. Okay. Okay. So then we will start with question number 6. So of course, we're talking about the Newton's laws of motion chapter. So let's start with question number 6. So if you have HC Verma in front of you, just go through the question. I'm going to explain it in a moment. Okay. Okay, so let's read through question number 6. So you are given speed versus time graph for a particle of a given mass, and at time t equal to 6 seconds, we have to find the force acting on the particle. Okay, so let's understand this. So there is a speed versus time graph, and you can see the speed is initially increasing linearly with respect to time. So that means it has a positive acceleration. Okay. And then after some time, the speed is constant for a certain duration of time. So that time, the particle is going at uniform velocity. And then later, the speed is reducing. So it's having a deceleration. So now, according to the values given in the question, so this is the speed versus time graph for a particle of 50 grams mass. Okay, so this appears to be 3 seconds. Okay, because they put 2 seconds somewhere here and 4 seconds somewhere here. And this speed appears to be 15 in meters per second. The time is in seconds. And then again, according to the data of the graph, this appears to be 5 seconds actually. So 4 should be somewhere in the middle. So I'm not drawn the graph very accurately, but and then this is 8 seconds. So definitely have to adjust this a bit. 6, 7, 8 seconds, something like this. So this is the graph. Now we are asked to find, now the mass of the block is given as 50 grams. So we have to find the force acting on it. The net force at t equal to 6 seconds. That is the C part which you have asked. So 6 seconds is somewhere here, you can see, at this point of time. So what you can see from the graph is that from 0 to 3 seconds, there's an acceleration of plus 5 meters per second square. Then in this part, so t equal to 0 to 3 seconds, the acceleration is plus 5 meters per second square. So basically, if you visualize the motion of the block at that point of time, there must be some force acting like it, which is giving it an acceleration, and the block speed is increasing. But then from 3 to 5 seconds, you can see the acceleration is 0 because it's having a uniform motion. So that point of time, the block is already moving at a speed of 15 meters per second, and it is having 0 acceleration. So there's no force acting on it. And now in the last part of the motion, you can see that from t equal to 5 seconds to 8 seconds, okay, the initial velocity at 5 seconds is 15 meters per second, and the final velocity at 8 seconds is 0. And the interval of time between these two, delta t, is 8 minus 5 or 3 seconds. So your acceleration, which is delta v by delta t, is minus 15 by 3, or the acceleration is minus 3 meters per second. So minus 5 meters per second square. That means during this time, 5 to 8 seconds, okay, the block has a velocity in this direction, but it has an acceleration in this direction. So there will be a force acting like this. So this F will be ma, but with sign convention, if we write it, it will be minus of 50 grams into 5 meters per second square. So it will be decelerating. At t equal to 5, if it had a velocity of 15, by the time we come to t equal to 8 seconds, it has stopped because of this force acting opposite to the velocity. So hope this concept is clear.
Yes, sir. Thank you, sir.
Okay. Now next in our list, we will move on to question number.
Sir, wait, do we have to copy now or you will give time later?
You can copy it down. Wait, you can copy it down. I'll just copy the questions. So next up after this, we will do question number 8. So just go through it. Okay, so let's understand the 8th question next.
Sir, one second.
Yeah.
Sir, I have a doubt.
Yes.
Sir, for question number 8, as we can see, sir, mass is 4 milligram. So if we
Hmm.
convert into kilogram, then it will be very small, no?
Yes.
So in these types of question, we should try to do it in grams or kilograms.
No, but you have to give ultimately the answer for the force. You have to give an SI system of newtons. So you have to convert to kg. You understanding, no?
Yes, sir, but it will be very small, no?
Depends, no? Because the time also might be very short, no? So when you're calculating while the mass is very small, the acceleration might be very high. So let's check it out and we'll understand. Okay. So first of all, let's understand the question. So there is a raindrop which you are assuming is a sphere of radius 1 millimeter and mass 4 milligrams, and it falls at a speed of 30 meters per second on the surface of a bald person's head. Now the drop splashes on the head and comes to rest. Okay. So assuming equivalently that the drop covers a distance equal to its radius on the head. So this is the key thing to understand about the question. Okay. We have to find the force. So what is the meaning of this statement? That assume that it equivalently covers a distance equal to its radius before coming to rest. So what that means is that, so let's assume that we are drawing a very sort of magnified diagram of the bald person's head. So this is the surface of the bald person's head. Okay. Now what is happening is that when the raindrop is just about going to make contact, it's a sphere like this. Okay. And at that point of time, that sphere has a downward velocity of, let's say, v, which is 30 meters per second. Okay. And the sphere has a mass of 4 milligrams, or 4 into 10 raised power minus 3 grams, or 4 into 10 raised power minus 6 kgs. That's milligram in kilograms. Okay. And it has a radius of 1 millimeter. Now what the question is saying is that next picture, by the time the sphere comes to rest, the rain droplet comes to rest, it kind of flattens altogether. Become like a surface of small surface of water. So by the time the velocity has become zero, the center of mass of the droplet has traveled through a displacement equal to its radius, which is 1 millimeter. Okay. So the initial velocity was 30 meters per second. The final velocity is zero, and during this time, the displacement was equal to 1 meter. 1 millimeter. So from that, what can we say about the acceleration or the deceleration, basically? So we'll use v square is equal to u square plus 2as. So from that, we'll get the a as minus of 30 square divided by 2 into 1 into 10 raised power minus 3 meters. Use this. Okay. So we can see from this how much the deceleration of the body is. So when it is in contact with the head, it is experiencing a deceleration of how much this will become now? Minus 9 into 10 raised power 2 divided by 2 into 10 raised power minus 3. So minus of 4.5 into 10 raised power 5 meters per second square. This is the deceleration, while the contact force is stopping. It's in the process of stopping the raindrop. Okay. So at that point of time, if you see at any in-between situation from here to here, okay, now, let's say the raindrop is gradually getting crushed like this. So while it is getting crushed, what forces are acting on it? There is its own weight acting. and there is some kind of a contact force, like a normal contact force, and that is giving it an acceleration in this direction. Okay. So we have this equation here that n minus mg, that is the net force, is equal to m into a. But here, mind you, that we should substitute the a as the magnitude of that, because we've already shown the direction. Okay, so it's 4.5 into 10 raised by 5 meters per second. This is acceleration with direction. This is with direction. The negative sign is coming in here. This is only the magnitude, because we already shown the direction in the diagram. So the normal contact force at this point of time will be m into g plus a. So now you will see that g will become insignificant. Okay, so m over here is 4 milligrams, so this much in kgs. But the acceleration is so much more, right? It is 4.5 into 10 raised by 5. So this is approximately same only, 4 into 4.5 into 10 raised power minus 1. So 4 into 4.5 is 18. So it's about 1.8 newtons. That is the contact force. Okay. So this is the proper solution of this question. Okay. You can of course ignore mg because it's very small compared to this and get away with it, and you'll get the same answer. But the proper way of solving it is that the net force is n minus mg. Now it so happens that mg is a very small amount of force. So if you neglect it also, you'll get the same answer.
Sir, how did that multiplication of 4 into 10 raised to minus 6 multiplied by 10 plus 4.5 into 10 raised to 5 become?
That's what I'm saying. Now, in this one, in this bracket, this thing, we are approximating it as 4.5 into 10 raised per 5, because 10 is very small compared to something to the power 5, no? Something into 10 raised per 5.
Yes, sir.
So it is like 4.50001 into 10 raised per 5. So that we are ignoring that part and writing it as 4.5 into 10 raised per 5.
So,
Yes.
but N is the force that the head is applying on the drop, right?
Yes. Yes.
But we were supposed to find like each drop.
The force that the droplet is applying on his head, no? So that one is the reaction for this, like action reaction pair, which understood, no?
Yes, sir.
So whatever upward force the drop is experiencing because of the head will experience the same equal and opposite downward force.
Yes, sir.
Okay.
Got
It has the same magnitude. Yeah. Okay. Now next on our list is the 10th question, I think. But 10th
so
question
just
involves, yeah, you can note this
so
down. Fine.
here, like, why did we took A as positive?
No, A is positive in the sense that, see, the direction of velocity is downwards. No? So that is why, as it is stopping, when we calculate by kinematics, we'll get A with a negative sign, because the sign is giving us the direction of A. So what is the direction of A? It is opposite to V. So that's how we know it is upwards. You understood, no?
Okay, sir.
And then when we are using the value of A in the free body diagram, there we are not writing it as a vector quantity. No? It's just the magnitude of it, because we already shown the direction with the arrow's direction, isn't it? So
Yes,
we won't
sir.
be using the sign convention over there. Whereas in the kinematics equation, we have used sign convention. That's where we are getting it with a negative sign.
Okay, sir.
Okay, so now moving on.
Sir, one second.
Okay. Okay, so next on our list was the 10th question, but 10th question actually students will be leaving out for the moment because we haven't discussed about spring force yet. I will teach you about spring force in the next lecture before we start friction. Okay? That is one of the last things we will do. So question 10 we'll discuss later after learning about spring forces, okay, or about springs in general. So next let's come to the 15th question. So go through the 15th question, we'll discuss. Okay, did anybody have a doubt in the 12th question by chance? Have you tried the 12th question?
Yes, sir. I have tried. It was a little bit tough.
But you got it, no?
Yes, sir.
Okay, good. Okay. Okay, now let's come to 15th question. So 15th question is about application of pseudo force. Okay, but the language is a little tricky. So it says that a person is standing on a weighing machine placed on the floor of an elevator. Now we have to assume that initially the elevator is at rest and then it starts going up with some acceleration. Okay. Then after some time it's moving with uniform velocity and finally it decelerates for some time and then it stops. So the maximum and minimum weights recorded are given to you and assume that the magnitude of acceleration is the same as the magnitude of deceleration. Then from that you have to find the true weight of the person and the magnitude of acceleration of the elevator. Okay. So let's understand the question first. So first of all, what you need to understand is that when you are standing on a weighing machine, what the weighing machine actually measures, there's no way the weighing machine can actually measure gravitational force. Okay. What it can measure is the contact force or the normal reaction. It can sense that through pressure sensors or through springs or whatever. So whenever we put a person or some object on a weighing machine, what the weighing machine does is it measures the contact force. Okay. So what this does is it measures the normal contact force. Okay. So the person, because of his weight, is applying a downward normal reaction on it, and the weighing machine is applying an equal and opposite upward normal reaction on the person, which is balancing his weight. So basically, in ideal situation, N is equal to mg. So that's how it measures its weight. Okay. So suppose normal reaction is, let's say, 900 newtons. Okay. Then the reading of the weighing machine will be this normal reaction divided by g, or 900 divided by 10. So it will be 19 kilograms. So it gives a reading in kilograms instead of a reading in newtons, because it adjusts its scale by dividing the value of normal reaction it has measured. It divides that value of normal reaction by the acceleration due to gravity, so that it can give you the true mass instead of the true weight. Okay. So this is the working principle of a weighing machine. Okay. So the accuracy of the weighing machine depends on normal reaction being equal to mg. So this is going to be the case only when the person and the weighing machine are both at rest in an inertial ground frame. There should be no acceleration involved and there should be no pseudo force involved. So this is only going to be true if in an inertial frame and at rest. So what will happen is in a non-inertial frame. So now let's take the situation of this question. So in question 15 now, what is happening is that when the lift is going up with an acceleration a0, which we don't know, at that point of time, the person of a certain mass standing on the weighing machine, what is the reading of the weighing machine going to be now? Okay, so to understand the reading of the weighing machine, you will have to make the free body diagram of the person.
Sir, it will be mg plus m a naught,
Yes.
no?
Very good. It will be this. You'll have to make the free body diagram in this, where in this frame it is at rest, because pseudo force and weight are being balanced by normal reaction. Let's say this is N1. So normal reaction in this case is mg plus ma0. Okay, so it is the true mass of the person into g plus a0. So this is what is happening initially in the problem. The lift is accelerating upwards. Then after some time, the lift is going with uniform velocity. Acceleration is 0. So that point of time, what will happen? It becomes an inertial frame. So at this point of time, the normal reaction becomes mg, which is the true weight. But then third part of the question, third part of the motion, now the lift is going up, but with deceleration. So it's upward motion with deceleration. So the acceleration vector is pointing downwards. And the question asks you to assume that this magnitude is the same as the upward acceleration earlier. So now when the person is on the weighing machine, you'll be able to understand that this time the normal reaction will become mg minus ma0. You make the FBD yourself and try to understand why that's happening. Pseudo force will be acting upwards. So it's acting opposite mg. So this value of normal reaction will be the minimum normal reaction. So it will give you the minimum reading. This will give you the maximum reading. Okay. And in between, if you've taken the reading, this would have given you the true reading. But the thing is, we failed to take the true reading. We only took the minimum and maximum. So from that, we have to understand. So this maximum reading was given to us as 72 kgs or whatever. And this minimum reading was given to us as 60 kg. So now we'll use those values. 72 and 60, and g is taken as 9.9 meters per second square. So now let's use that. Okay. So from this you can see that m into g plus a0, okay, is actually 72g, okay, and m into g minus a0 is 60g. Okay, so from this you can see that we just add the two equations, 2 mg is equal to 72 plus 60 g. So the true mass of the person is 66 kg. And therefore, substitute this back in either of the equations. So here I've done equation 1 plus 2.
So,
Ethan, just a minute now. Ethan, you have to read it from the question no, which is given. That's why I said read the 15th question. It is given to you that the minimum value of the normal minimum reading is 60 kg and the maximum reading is 72 kg. So we know that that's how we know that N1 will be 72 G and N2 will be 60 G. You know, it was given in the question. Yeah, Beta, you had a question?
so I couldn't understand that minimum reading part, like the equation you got.
Achha, so for that you have to make the free body diagram. So I told you to just try making the FBD yourself. Like I made the FBD for this situation when it is accelerating upwards. I made the FBD and showed the direction of pseudo force and all that. So now you do that yourself. Okay, like I see, like in the above diagram, I made the FBD for this situation. Like this, you make the FBD for this equation also. So try to make it yourself and understand how you'll get this equation.
Yes, sir.
And now if you substitute this in equation 1 or 2, whichever, you'll get the value of this thing, A naught. Okay, so let me know if you got the equation, this one from the FBD.
Yes, sir. Got it, sir.
Okay, good.
Sir, the answer should be 1 by 1.1, no, meter per second square. Sir, the answer is coming as 10 by 11 meter per second square.
Okay, people. So now let's move on to the next question.
Sir,
Yes.
the acceleration, the previous question was 10 divided by 11 meter per second.
Which one?
The one we just did, question 15.
15th question में
Acceleration is coming as 10 divided by 11 meter per second.
it's coming 10 by 11, is it? Yeah, so that's 1.2 now approximately. Yeah. No, it's not 10 by 11. Okay, let me check.
Sir, I am also getting 0.9.
So you're also getting 0.9.
Yes, sir.
Okay, just let me check the solution. So maybe I made some calculation mistake. Let me check. So we have 66 into G plus A naught is equal to 7.2, 72 G. So this is correct, 72 by 66. Let's simplify this a little further actually. So we write it down. So this is this is 1 by 11 of 9.9. So it is coming 0.9. Yes, so I must have made some calculation mistake. It was not 1.2, it was 0.9. Oh, I know. I made a calculation mistake. This was not 8 by 66. This was 6 by 66. Okay, so thanks for pointing that out. That completes this question. Please note this correction. Okay. This I had written it by mistake as 8 by 66. It's 6 by 66. So anyway, so this is the correct value of A naught, whereas the correct value of mass we had already got here. Correct. Now this correct. Now moving on to 20th question.
So 19th is left.
Oh, 19th is also left. Yes. Do all these three, 19, 20, and 21. So let's start with 19 then. So in 19th question, there is this equation of a hot air balloon which is experiencing buoyant force, okay, of capital B in the upward direction. So that buoyant force acts because a hot air balloon typically has helium inside the balloon. So helium is lighter than air. So it ends up experiencing an upthrust or buoyant force, just like a floating object in water experiences that similar kind of thing. So that buoyant force is given to us as capital B upwards. Okay. And there is also an air resistance force which acts opposite to the direction of velocity and proportional to it. So we have to interpret this statement correctly, okay, that the air resistance force acting on it is opposite to the velocity and direction and proportional to it. So if the balloon carries a mass m and is found to fall down near the Earth's surface with a constant velocity v, how much mass should be removed from the balloon so that it can rise at a constant velocity? So let's understand this question next. Okay, so let's say this is our hot air balloon and we have suspended some mass m, and as a result of this it is falling with a constant velocity v. Its acceleration is 0 initially. So the forces acting on it at this point of time will be the buoyant force, okay, and there will be air resistance force also, and the direction of that air resistance force will be opposite to the velocity. So this is air resistance force. Now it is opposite to direction of the velocity vector. Okay, so velocity vector is downwards, so this is upwards, and it is proportionate in magnitude. So this means that the magnitude of this should be equal to some constant into. Okay. And of course, the weight of the entire thing, which we'll take as mg. Okay. So acceleration is 0 in this situation means that buoyant force plus air resistance is balancing mg. So buoyant force plus some constant of proportionality into v is equal to mg. This is our equation number 1. Now next what we do is we reduce the load on the balloon by removing some mass. So we have removed part of this mass, let's say. So what we are left with is now m prime, which is m minus delta m, the amount of mass that we have removed. And now we observe that the same balloon is going up with the same speed, constant speed v, the same as the speed it had while coming down, but now it is going up with that. Okay. So in this situation, the forces that are acting on the balloon will be buoyant force, okay, but air resistance will now act downwards, and the weight will also act downwards because air resistance is opposite to velocity. No? So it is having a direction which is going to switch now because the velocity is upwards, so air resistance is downwards. So now the acceleration is zero in this situation. It implies that buoyant force balances the sum of the air resistance plus the new weight. Okay. So B is equal to kV plus m minus delta m into g. This is our second equation. So if from these two equations you want to eliminate kV, you can see kV from the first one is mg minus buoyant force. From the second one, kV is equal to buoyant force minus m minus delta m into g. So we have the relation that 2mg minus delta mg is equal to 2b. So the amount of mass that you are removing is this much. Or you can also, I mean, whatever you need to calculate, you can calculate from these two equations. So yeah, here you had needed to calculate the mass removed, so that would be like this. So anyhow, I'll just minimize this a little. This is question number 19. So it's an application of free body diagram and all that, but it's a bit of an unusual question because it involves these other types of forces like buoyant force and air resistance, not the regular type of forces you're used to solving with, like normal reaction, tension, and those kind of things. Okay. In that sense, this is a bit of an unusual question. Sorry, I've got this in reverse. It should be minus of this because I'll take delta mg that side now. So you'll see delta mg is 2 times mg minus buoyant force. So delta m is 2 times m minus b by g. This kind of thing. Okay, people. So make a note of this, and then we'll come to question 20. Okay, let's come to the 20th question next. Just a moment, I'll have to reshare the whiteboard. In the meantime, just go through question number 20, we'll discuss. Okay, so empty plastic box of mass m is found to accelerate up at the rate of g/6 when placed deep inside water. So basically,
Sir, your
again,
screen
this
is not
question.
visible.
Yeah, I told you that I'm restarting the screen. So in the meantime, just go through 20th question. So it says empty plastic box of mass m is found to accelerate up with an acceleration of g/6 when placed deep inside water. Now, how much mass should be put inside the box so that it may accelerate down at g/6? So again, there's an application of that concept of buoyant force acting. So the empty plastic box has a tendency to float in water because there is buoyant force acting on it. So that is why if you place it deep inside water, it will tend to accelerate upwards because the buoyant force in that situation exceeds the weight. So that concept has to be used over here.
Are you sharing the screen?
Yes, I will be sharing the screen. I told you I have to restart the screen. Okay, so now in this question, when the box is empty and you placed it deep underwater, so let's say the box's own mass is some m, and it accelerates upwards because buoyant force acts on it, and that buoyant force exceeds its own weight. So we have b minus mg is equal to ma, and that a is given to us as g/6. So from this we can see b is equal to m into g plus a. So m into. So buoyant force is equal to 7/6 times the weight. The box's own true weight. Buoyant force is more than it by a factor of 7/6. Now, next up, what we are doing is we are placing some mass inside the box. Let's say we fill it with a certain amount of sand or something. Okay. So we place some mass, capital M, inside the box, and again place it deep underwater. So this time, what we observe is that it starts accelerating downwards because of the additional weight pulling it down at that same g/6. So this time the forces acting are the same amount of buoyant force because buoyant force depends on the size of the box. The size of the box has not changed, but the total weight of the box has changed. Okay. As a result of that, now you can see the new weight minus the buoyant force is the new mass into A. So this time you can see that from this we can write m plus mg minus b is equal to m plus m into g/6. Okay. Because a is equal to g/6. So from that we can further write m plus m into g into 1 plus 1/6, sorry, 1 minus 1/6 mistake. Will be equal to buoyant force. Okay. So this was our first equation. This is correspondingly our second equation. So substitute this value here. So you can see you will get m plus m into 5/6 g is equal to 7/6 mg. So 5 times m plus m is equal to 7 times m. So capital M becomes so this is the solution to this question, which is the 20th question. Now moving on to 21st question. Okay, let's go ahead and complete the 21st question now. So 21st question takes you back to vector algebra a little bit actually. So let's understand how we'll solve this. So statement of the 21st question is that there's a force acting on a particle which is given by this relation F is equal to V cross E. Okay, so this kind of a force acts on a particle, okay, moving at a velocity V, where A is basically a constant vector. Okay. And it's also given to us that I think something about the direction of A will be given. A is a constant vector in the horizontal direction. So it is a horizontal constant vector. It might be towards the north or south or something like that, or east, whatever, but it's perpendicular to gravity. So now, given that the mass of the object on which this force is acting is m, what we have to do is we have to calculate the minimum speed which the particle of mass m must be given so that it moves undeflected and with constant velocity. So undeflected means that the direction of velocity is not changing. Okay, and constant velocity means that, I mean, by constant they mean that neither the direction nor the magnitude of velocity is changing. So that is the idea basically. Just a moment. Yeah. So now suppose we understand this equation this way, that let's say this is our horizontal plane. So this xy plane, this is a horizontal plane. And therefore, obviously, the z axis now is becoming the vertical plane and the vertical axis. So the vertical axis. Okay. Now, let's say our particle of mass m is over here, and suppose the vector A that we have is like this. In the above equation, the vector E that we have is like this. Okay. So now if you look at it, the forces acting on the particle, okay, on that same particle, the forces acting are going to be, so there's going to be mg acting on that particle, which will act vertically downwards. Okay. And now we want to project the particle with such a velocity. Now the particle should be given a velocity such that its acceleration becomes 0, so that it moves with constant velocity. So constant velocity means rate of change of velocity should be 0. So acceleration is 0 means that the net force should be 0. So if the net force is 0, that means I must have this other force which acts in this direction. This other force which is given by A cross, rather V cross A, this force should be acting like this, and its magnitude. So this force should be equal to mg along k cap, or basically this force should be opposite to the gravitational force. So V cross A should be equal to mg k cap. Okay. Now here you're seeing that suppose my vector A I've already taken as A I cap. So that means V cross A should be equal to mg k cap. This implies that B cross A I cap should be equal to mg k cap. So now we can understand this either by using right hand thumb rule. You want V cross A to point upwards. So what should be the direction of V? you'll understand that the direction of V should be like this. If you give it a V like this, then V cross A will point upwards. So basically, V should be some V minus J cap. So that this becomes mg k cap. So AV k cap, AV k cap will become mg k cap. So it should be projected with a velocity of mg by A in magnitude, but along minus j cap in this case. So the magnitude of this velocity with which it should be projected is mg by A, so that the net acceleration becomes 0. Okay, so just make a note of this, people. So again, this question is more about vector algebra. Basically, you have to understand this relation. This is vector algebra relation as per this diagram.
So can you explain again? I wasn't able to understand.
Okay, so we have selected our coordinate frame such that mg, which is vertically downwards, mg is a force which is acting along the minus k cap direction. So therefore, F should be a force which is along the plus k cap direction, and its magnitude should be equal to mg. That's the only way the net force will become 0. Understood now?
Yes, sir.
Okay. So if my vector A is along the x-axis, it's like this A I cap, then what is the force F? It is V cross A, where A is along the x-axis, and that should be pointing along plus k cap. So you have to just solve for the V such that V cross A is mg in magnitude and it points upwards. So that is now what this vector diagram is showing you. That if you give it a velocity along the negative y-axis, then this V cross A will point along the plus k cap axis. Now in this you can see that this is V minus j cap cross A I cap. So that is V into A into minus j cross I. Now you know that that is equal to k. You know that from the cross product symmetry. You know that I cross j is k. So j cross I is minus k. So minus of j cross I is again k cap. So this cross product algebra has been used over here. Okay, so hope this is clear now.
So,
Yes,
why do we need to make the net force 0 over there?
because that is the condition of the question, Beta. The particle is the question itself is saying that the particle should be given a velocity such that its acceleration is 0. So that is the interpretation. No? If it's
Oh, okay,
moving with
sir.
constant velocity, no? So the question is asking कि ऐसा कौन सा velocity से उसको project करना चाहिए so that it's going to move with uniform velocity. So uniform velocity का मतलब ये हो गया that we want to make a net force 0. So basically we have to balance the weight with this other force, which is F V cross A. So that velocity should be adjusted in such a way that V cross A is opposite to mg in direction and equal to mg in magnitude. So that is the solution over here. Okay, people. So hope this question is clear. So with this, we'll conclude today's session, and we will discuss the remaining questions in the next session and then move on with friction. So next lecture that we have, we will start friction and we'll complete any other doubts from this as well as the module exercises. So please continue with your module exercises also. So that's it for today's session, people. Wish you all the best. Have a nice day.
Can you send a PDF of NLA module?
Thank you, sir. Bye, sir.
Thank you, sir.